Hello everyone, welcome back. So in this video we are going to understand the game 24, right? 24 games. We have seen already the first version of this problem. So we are going to understand the second version of the code is hard version. Okay. What the question is saying that, let's understand. Question is saying that we have given an integer array that is called card of length 4. But we have given a array that is known as card. Okay. Where length is 4. You have 4 cards, okay, each containing a number in the range 1 to 9. What you have given? You have given a card, right? And you have 4 cards in that, where each number in the range 1 to 9. Now question is saying that you should arrange the number of this card in a mathematical expression. How? Using these operators. You can say plus, minus, star, and divide. These are the 4 mathematical expressions we have. So it is saying you should arrange the numbers on these cards in a mathematical expression using this, and parenthesis, you can take this and this to get the value 24. Okay, you are restricted with the following rules. What are the restricted rules are there? Very first, it is saying the division operator represents real division, okay, not integer division. For example, if you have 4, you can divide by 1 minus 2 by 3, right? So when you do this, right, you know that this is a 4, right? So 1 minus 2 and divide by 3, right? So very first, what you will operate? You will operate this operation. This operation is nothing but it will give you, let's suppose, 1, okay? And you have to divide by 3. What will come? It will come 4 into 3 by 1. It is 12. Every operation done is between two numbers, okay? So in the particular, we cannot use this operator in unity operator, okay? For example, if we have this number, if we apply all of this, it is not allowed, okay? It's very first, you have seen the division operator that represent a real division, not an integer division, okay? Similarly, if we have this one, so it will not get applied onto the unity operator, okay? Now it is saying you cannot concatenate numbers together. How? If card is this 1 2 1 2, the expression 12 12 is not valid, okay? So we have to return true if you can get such expression that evaluates to 24, right? You have to return true, otherwise return false. For example, we have given this card and card gives you 4187, right? And we have to return true, okay? So can we say that if we have this card number, so if we'll apply, very first we'll apply like this: 8 minus 4 multiply 7 minus 1. So 8 minus 4 is 4 and 7 minus 1 is 6. 4 into 6, right, is 24. It will give you 24. It's true. Then we have this number, it will never give you 24, so return false, okay? And this is the constraint we have given, that cards dot length is equal to 4 and 1 is less than equal to card at I is less than 9, okay? So this is the problem statement we have given. So can we say that you have given, let's suppose we have given 4 numbers we have given, right? 4 numbers we have given, right? Between what? Between 1 to 9. And we can use, right? We can use plus, right? We can use minus, we can use multiply, and we can use the divide. So these are the operators, mathematical expression operators that we can use here, right? And some parentheses also we have given. We can say parenthesis, right? Like this and this, okay? Why? To combine them to at a time, right? If we can build expression that is equal to 24. Can we say that if it is equal to 24, we will return true, right? Otherwise return false. This is the statement is saying that. So rules, some rules are there, as you can see here. What is the rule is here? Rule is to, if the division is real, okay, if the division is real, means fraction are allowed, you can say. It means fraction are allowed. Can we say that? Then it is saying unity operator, right? Unity operator are not allowed. So no unity operator. Okay, these operators are not allowed, like minus you are doing. So no -1. Okay, this is not allowed. Then what we have given, the third we have given is you can't glue digit together. Okay, you can't glue digits together, that you have seen, right? So these are the three things we have given. Okay, like glue means this and this, we cannot do that. Okay, now let's understand through the example. You understand what are the things we have given? Very first rule is we have given is division is real in which fractions are allowed. Okay, then it is saying no unity operators are allowed, or like a minus on this one. Okay, then you can't glue together the elements, you can say digits together. Okay, then understand an example. Let's suppose I'll take this example 4187 4187. Yeah, this is the array we have given. Okay, and our goal is to make 24, right? What do we make? 24 we have to make. This is our goal. Output should come here, right? So think in the stages, right? Let's suppose very first you pick two numbers, right, and combine them with the operator, right? But you have to put back to the result also. Let me tell how. So if we will pick the two number, right, what I'm trying to say, very first we should think in stages, right? So let's talk about, we are going to pick here element, not this one. Let's take this time. The possibility is possible, we will use, we will take this okay, let's take this 4 and 8, right? Can we take? So if we'll pick these two elements, let's call it let's call this pick 8 and 4. Okay, so when we'll apply one operator, okay, let's call 8 minus 4, we can say what is coming, 4 is coming, right? What is the remaining is there? Remaining is 4, 7 and 1, we can say that. Okay, because we have picked this time 8. Okay, let's pick this time 7. If we'll pick 7 and let's take one more element is 1. Okay, what is the data is coming? 7 minus 1, it is coming 6. What is remaining? We'll say 4 and 6 are remaining. Okay, now think we are going to combine them. Okay, let's think if we'll have the 4 that we got here and 6 here, just multiply this, we'll get 24. If we will do this through the expression, we can say rebuild with parenthesis. Okay, can I say 8 minus 4 into 7 minus 1, and this is nothing but 24, this will be 24, right? So either you do by this way, right? Very first is winning the path, right, where you got the 4 and 7, you have picked the elements, two elements, then you have combined with an operator, right, and we'll put this result back to the result, and we will repeat this until one number remains. Until the one numbers is not coming, we'll keep repeating this one. The very first, this is the way where we will win the path, and other way we will do through the expression. You can rebuild with the parenthesis where you can get the result. Let's understand through the pointer movement. Okay, very first, if we want the pair selection, okay, we want the pair selection where we think that we don't have any pointer movement like the 2 pointers algorithm, but we want the pointer selection pair at each recursive level. Let's suppose I'll say some level is there. Okay, what is the level is here? 0. When the nums, what are the nums? 4187, right? We'll say 4187. So if this is our nums we have and level, current level is 0, can I say if I will point to 8 and j is at 4? So we can try how? We'll say, okay, try 8 minus 4, you will get 4. Then you can say 8 plus 4, it is 12. Then 8 into 12 will get 32, and if we'll divide 8 by 4 will get 2. Similarly, if you apply 4 minus 8 will get minus 4. If you'll do 4 by 8 will get 0.8, 0.5, right? So these all are valid, right? All if valid, we can say, if all are valid, right? So when we try I and j, 8 and 4, right? If we'll apply, if we'll try all the operations, right, minus on these two, right, these are the chance that these are maybe valid, right? If all are the valid, so these are the chances, these are the values, right? Let's take 8 minus 4 very first. So when we take 8 minus 4, it is give you 4, right? So what is the next element remaining that we have seen? We have seen that 4, 1 and 7, right? Means we remove I and j and push the result here, right? It means that the value we have here is nothing but what? We have removed the value I and j. We have removed from here and we have pushed back here, right? The result we have got from here, we have added here, right? So if we remove I and j, right, and the result that we have tried, it will push back here, right? It means we'll have the new array is like this. Can we say that? So what we can do, we can take the array list, not in the array. So it will become little easy for you, right? And then you can try this way. Now think, now we are at level 1. When we reach level 1, it is nothing but nums. We have 4, 1 and 7. Similarly, we'll apply these rules, right? Once we will apply this rule, the possibilities are there. What? Let's understand again. Let me clean it. So this time level is 1. Then we have nums. Nums is 4, 1, 7 now, right? That we have got the result from the level 1. So this is the result from the level 1, right? Now think that we will take I is 7, okay, and j is 1. Can we say that? So if we will take this, so if we'll try all the possibilities, 7 minus 1 is 6, 7 plus 1 is 8, 7 into 1 is 7, and 7 by 1 is 7, and we can say, what are the possibilities are there? 1 minus 7 we can say 6, 1 by 7 is, it should come around what, 0.14 we can take for now. Okay, so these are things will come. Now once we have all of these, right, we have to take the elements, some of these. So let's take some element. Okay, 7 minus 1 I am picking, it is nothing but 6. So can I say, after applying this result, 1 and 7 we have tried, the remaining is what? Previously it was 4, now new is coming 6, 4, 6. Now we will try similarly the level 2, right? Level is 2, nums we have is 4 and 6. Can we say that? We can say that. So similarly, if we will say I is 4 and j is 6, can we say, let's try, where we'll say 4 into 6 is 24. You found the result. Similarly, we'll try 4 plus 1, that is 10, 4 minus 6 is 2, 6 minus 4 is 2, 4 by 6, 6 by 4, like that we will got, but we got the result here. Okay, means this way we will keep increasing our level and we'll keep finding the pairs, right? Very first we keep finding the pairs, when find the result, and we'll push back the result, result will be pushed into the result, right? And we'll remove I and j selections, right? Means this is what we backtracking, right? This is what we backtracking the picked pair, and once we apply all the operations, we'll recurse it. If we are stuck, we'll do undo and we'll retry again these options. I hope you understand, right? So can we say about the intuition is that very first what we should do, right? So at any time, if you have multi set of number, right, we will pick two elements, right? What we will do, we'll pick two elements, we'll apply the every possible operations and will recurse with a new set, right? Very first we have seen the array was in the 4, then we have converted into 3, then we have converted into 2, right? Means every time we have a set of numbers we have, so we'll pick any two numbers, we'll pick, let's suppose, and we'll once we will pick any two, we will apply every possible operations, like for the all these operations, plus minus, multiply and divide, and we'll recurse this operation and we'll get the new set, right? Every time means we'll get the new set in the all the levels, we can say level 0, level 1, 1, 2, like that we will get, and we'll stop once yeah, when we only one number is left. Let's suppose we got 24, right? So when we'll reach the 24, we will say, okay, this is our tiny, let's suppose call 24, and we got it. So it's a, let's suppose epsilon, right? And we'll say, okay, we got the our tiny epsilon for the floating point, and it's fine, we are good. So just stop it, right? Means very first what we will do, we'll pick the two elements, we'll recurse, we'll apply all the possible operations, we'll do the recursion, we'll find the new set, we'll apply to the same, we'll stop only when only one number is left. If it is 24, okay, fine, we are done, like that we will do. Okay, so this is our what we call, this is our intuition. Think about the implementation, how we are going to implement it. Okay, how you are going to implement it. Very first that we have given is int, right? So very first we will convert into a list of double. Okay, then we have to take the base cases. If the list has size 1, right? If the list is having size 1, whatever the list we have, so just we'll do absolute value will take, and we'll say x minus 24 will check if it is less than epsilon 6. Can we say that? If it is less than 6 means 10 to the power 6. Okay, if it is less than this value, we'll say okay, just return it. Otherwise what we need to do, otherwise we have seen that if there is a unordered pair, we have to get the I and j, right? Where I should be less than j, like that. So we can do the minus, or we can apply all the operations, right, easily. Okay, so we'll take an unordered paired and we'll build a list without I and j, correct? We'll generate all the valid result with plus, minus, multiply, and this. If both operator, this one and minus and divide, if both we are applying, right, so we will get the valid results. Okay, then for each result, let's suppose for r, we'll push the r we'll do the recursion again on the each level, right? We have seen, and we'll pop the R when we'll do the backtrack, and finally we'll return false if no sequence works. Let's understand how to do that. Okay, so this is the structure of method where we have given these cards, right? So as I told you, what we need to do, we have this we'll create the list, right? We'll convert into the list. So one by one we'll get all the card, 4-digit card we'll get, and we'll add into the card on the list, right? And then we'll check if the result reach to the destination or not. Yeah, 24 we got or not, right? So this way we'll build another we call this method, right? And will generate all the possible results. Let's suppose we are passing a result in the PR. Let's suppose call two elements we have, A and B. So this method will generate the all the result of combining, let's suppose, A and B, and we'll get A plus B, A minus B, B minus A into B, A by B, like that. We'll get all the possibilities. But if B is not equal to 0 and A is not equal to 0, okay, only in that case we'll do divide A by B and B by A, right? Understood? So these operations will apply. Let's see this method. Okay, so very first you pass the list, right? And then you will check the length. If the length is equal to 1, we'll not do anything. We'll just do the math dot absolute value will pass, right? You will check the current value minus 24. If it is less than equal to 0.1, right, means approximately 24. We'll check. We only have one element left and check if it is approximately 24. So it should be less than equal to 0.1 maximum. Okay, if it is that, we'll return here, right, absolute value. It will give you the result, okay, in the boolean yes or no, okay, because we are comparing the value. Very first you take the math absolute value, it will give you the result. If it is less than equal to this, means it will return the true or false. I hope you understood. Further, if it is not, the size is not great, size is greater than 1, let's suppose, so we'll traverse for all the digits. Okay, we want the pair, so we'll go I and J. Understand? So I will start at 0 and J will start at where? I plus 1. So we can get all the pairs. Understand? Then we will create a new list with the remaining numbers, and we'll keep adding the new result, new list, we can say, right? So we'll apply, because we want the recursions, right? Recursive calls we need. We want the uh, new result, new list, right? So we can do the backtracking. Okay, we'll do the backtracking later. We'll understand. We'll create the recursion, we'll create a new list, so that we'll create a for loop, and we'll traverse over the list. We'll check all the, it is not equal, right? A not equal to J, A not equal to I. We'll add that element in the new list. We'll get from the list and we'll add on to the new list. Okay, I hope you understand. Then we have these two values we can get from the list. These two values we'll get from the list, right? And we'll generate all the possible results as we have done for there. So we'll perform every operation one by one, right? And so on the our list we will get from the list, right? So this is the same method that we are talking about, right? Where we have to generate the possibilities A and B, so it will generate all the possible things, right? Okay, so it will generate all the possibilities, and we'll check all the possibility, we'll keep adding onto the new list. Then we'll check have we reached to the, we'll pass the new list, and we'll check if it is reached the destination, means the base case, right? You know the recursion will keep checking all the result. Whenever the big problem is there, it will keep uh, uh, into the sub problems, you can say, right? And the smallest problem, whenever it will reach the base, right, it will give you the result. What we will do, we'll convert the, let's suppose we have the 4-digit elements we have, then we'll convert into the next level. We'll get what? Two level we'll get, then we'll get 3 level, right? Like that, all the level it will give you, it will keep shrinking the the given list, we can say, right, or cards. Finally you will reach to the destination. Once you will reach to the destination, means base cases matches, right, means we got the 24 nearby 24, and we'll say return true. Otherwise we'll keep removing the new list size from here and we'll backtrack the result. So we'll backtracking will remove the result from the list. Okay, and then we'll return false if it is not happening. Okay, so this is what I have in this video. Let me know the comment section that you understood or not. If you have any doubt, let me know in the comment section. We'll talk more in there. Okay, thank you guys, thank you for watching this video. I'll see you in the next one, and please make the notes, because this is a very interesting problem where you will understand the recursive calls as well as the recursion. You are also doing the backtracking, right? It is very important to understand the how the pointer moves on the pairs and how we are reducing the result into a set, and we are preparing a new set, and we are backtracking again. Okay, so thank you. I'll see you in the next one, and for now, bye bye.